700 milliseconds. That is how long Grok Voice Think Fast 2.0 takes to produce its first audio token, down from 1.25 seconds in version 1. For voice agents, that gap is the difference between a conversation and a demo. Today, we break down what XAI actually shipped, where it sits against the competition, and whether you should be migrating anything on Monday. XAI released Grok Voice Think Fast 2.0 as a speech-to-speech model purpose-built for voice agent workloads. 4 things changed in a meaningful way. First, reasoning now runs concurrently while the user is still speaking, not after the utterance ends. That is the architectural move that drives the latency number down to 0.70 seconds time to first audio. Second, reasoning token usage dropped roughly 40% compared to version 1.0. That matters for cost at scale, and I will come back to it. Third, speech-to-text accuracy improved. XAI's own evaluation across 24 languages shows a 1.5x to 2.0x gain over DeepGram Nova 3 and 11 Labs Scribe V2 in clean audio, scaling to roughly 10x in noisy, compressed telephony environments. That last number carries a medium confidence flag. It comes from XAI's internal evaluation data, not an independent third-party audit. Fourth, on the benchmarks, Number 1 on Tao Voice for agentic performance at 56.5%, and number 2 on the Artificial Analysis Speech-to-Speech Quality Index at 82.9%. Let's talk about what concurrent zero-latency reasoning actually means in practice, because the framing matters. Traditional voice pipelines are sequential. You wait for end-of-utterance detection, then you run STT. Then you hand off to the language model. Then you synthesize audio. Every stage adds wall clock time. What XAI is describing here is a pipeline where the model begins reasoning before the user finishes speaking, overlapping compute with audio ingestion. The payoff is that TTFA drop. The open question, and this is not answered in the release notes, is what this does to streaming concurrency limits and infrastructure cost under high-load enterprise deployments. If you are running thousands of simultaneous sessions, the compute profile of always-on concurrent reasoning is fundamentally different from a burst-on-utterance model. That is the first thing I would stress test before committing to production. The competitive shortlist from the benchmarks cited in the brief is 4 players. 2 peers, 2 specialists. On the peer side, OpenAI GPT Real-Time 2.1 scored 79.1% on the Artificial Analysis Speech-to-Speech Quality Index and 45.7% on Tao Voice. Grok 2.0 beats it on both, 82.9 and 56.5. Google Gemini 3.1 Flash sits lower, 69.5% on the Quality Index and 37.7% on Tao Voice. So on these 2 benchmarks, Grok 2.0 leads the peer group. Now the specialists, 11 Labs Scribe V2 and DeepGram Nova 3, are dedicated transcription systems, not speech-to-speech models. XAI claims a 1.5x to 2.0 STT accuracy advantage over both in general conditions. I want to flag the confidence level here. These comparisons come from XAI's own evaluation data. Independent third-party head-to-heads are thin in the current literature. If your use case is pure transcription accuracy in clean audio, I would not retire Scribe V2 or Nova 3 based on vendor benchmarks alone. If your use case is end-to-end voice agent performance, latency, agentic task completion, and transcription together, the benchmark picture is more compelling. 3 things I would want answered before signing an enterprise contract. 1. Pricing. The brief does not surface detailed pricing tiers for streaming token versus per-minute billing. At 40% fewer reasoning tokens per turn, the cost story could be good. But you need to know whether you are paying per token, per minute, or per session before you can model it. 2, the 10x telephony accuracy claim. That is a striking number, but the release notes do not describe what happens when audio degrades beyond the threshold where that advantage holds. What is the fallback? Does the model gracefully degrade or does it fail hard? For a telephony integration, that failure mode is your SLA risk. 3. Concurrent reasoning under load. I mentioned this in the architecture section. The compute model for always-on reasoning is different. Rate limits, burst capacity, and cost per concurrent session are all unknowns from the public release. Here is how I would triage this. If you are building a net new voice agent and you are not already locked into a provider, this is worth a serious evaluation this week. The benchmark numbers are the strongest in the peer group on the metrics that matter for agentic workloads. And the latency improvement is real and architecturally meaningful. Run a proof of concept against your actual telephony audio. Noisy, compressed, real-world samples, not clean studio audio. If you are currently running a decoupled STT plus LLM plus TTS stack, and you are hitting latency ceilings, the concurrent reasoning architecture is the right direction. Whether Grok 2.0 specifically is the right implementation depends on the pricing model, which is not fully public yet. Get a quote before you model the migration costs. If you are a pure transcription shop, batch jobs, clean audio, no real-time requirement, the specialist case for Scribe v2 or Nova 3 is not broken by this release. The STT comparison is vendor-sourced, and the use case is different. Watch. Do not move. Grok Voice. Think fast. 2.0 is a real architectural step. Concurrent reasoning during speech ingestion is the right way to attack voice latency, and the benchmark numbers back it up on the metrics that matter for agentic work. The gaps are pricing transparency, independent STT validation, and concurrency behavior under load. Those are not reasons to ignore it. They are the 3 questions you ask in the first vendor call. Links to the XAI release notes and the artificial analysis benchmark data are in the description. If you are already running a voice agent in production, drop your stack in the comments. I want to know what the real migration friction looks like. See you next episode.